Howdy! In this video, we're going to find the angle of depression. From the top of a 210-foot tall cliff, David observes a lighthouse that is 430 foot offshore. Find the angle of depression from the top of the cliff to the base of the lighthouse. Okay, so angle of depression is the angle that you look down at. So let's assume David has no height. His head's right there. There's David, okay. And the distance from him or from the top of the cliff to the water is 210 feet. Kind of interesting they drew the water over here. Not sure how that really works, but anyways. Okay, we're trying to find this angle, which is you have an imaginary line shooting out. It's through space, right? Through the air. That's this line here, the dashed line. The angle that you look down at from that imaginary horizontal line, that is called your angle of depression. Now, assuming that the ocean is also flat, horizontal, that would mean that these two lines are parallel, which means that this angle of depression, by remember high school geometry, alternate interior angles, equals to that angle right there. So let's say we want to call that theta or something, and we could call this angle B, but I'll just go ahead and call it theta. Those are equal angles. That's what we're trying to find. Finding that angle of depression, that is that angle theta, which is equal to that angle theta. I'm marking it down here because look, we need a triangle in order to use trigonometry to solve this problem. We need a right triangle. Well, here's a right triangle drawn, right there. There's a right triangle. Now you could also, here's another way to do it. You could draw the line straight up to this imaginary horizontal line. I guess the reason that would be maybe a less likely way to do it is just because that's an imaginary point in air that doesn't really exist and can't be marked in the middle of the air. But this is a real point where the cliff meets the water. So we're going to go with the triangle at the bottom there. Okay, now from here, what do we know? We know that the height of the cliff is 210 feet and the distance from the cliff to the bottom of the lighthouse is 430 feet. And we have a right triangle and we're solving for an angle. So this uses trig. So you might remember basic trig, I hope. We're going to refer to SOHCAHTOA, SOHCAHTOA, means sine equals the opposite side over the hypotenuse. Cosine equals the ratio of the adjacent side to the hypotenuse, and tangent is the ratio of the opposite side to the adjacent side. So first let's label the hypotenuse. The hypotenuse of this right triangle is always going to be opposite the right angle. So it's that line right there, the distance from David to the bottom of the lighthouse, which I don't really know and I don't really care to find either. So we're going to try to leave that out of the equation. If this is the angle theta that we're talking about down here, then relative to theta, 430 feet, that bottom side of the triangle, that is touching theta, which makes it the adjacent side of this right triangle. 210 feet is opposite from that angle theta. So that's the opposite side of the right triangle. So we get to choose. Do we want to use sine, cosine, or tangent? The easiest, technically you could use any, but the easiest of those three choices is going to be the one that does not involve the hypotenuse because I'm not given the hypotenuse, nor do I care to find it. I'm trying to find the angle. We do know the opposite and adjacent, which makes tangent the best choice. You could use Pythagorean theorem to find the hypotenuse and then use any of the three, but that's just extra work. So we're going to use tangent, right? So tangent of the angle theta is equal to the opposite side divided by the adjacent side, that ratio. Well, in this example, the opposite side is 210 feet and the adjacent side is 430 feet. Let's rewrite that and reduce it a little bit. That reduces to 21 over 43. Well, to find theta, we need to use then inverse trig. So theta is equal to tangent inverse of 21 over 43. Because remember, the inverse trig functions reverse, really any inverse function reverses the input and output. So the 21 over 43 becomes an input, theta becomes the output. To approximate that, we will need a calculator. So we're going to use, let's make sure the mode is in degrees. Mine is. Okay. Then we're going to hit tangent inverse of 21 over 43. And that gives us an angle of about 26.03 degrees. I'm going to round that to just 26 degrees. That is that angle of depression, 26 degrees right in there.